Okay, then here we are in question 1. The diagram shows the graph of y equals the modulus of f of x, where f is a cubic polynomial. We want to find expressions for the two possible functions of f of x and write each expression in fully factorized form. Well, okay, what we need to know is we need to know the factor theorem, basically. And what's the simple expression of the factor theorem? If x equals a is a root, right, then what does that mean? It means that x minus a is a factor, right? So, for example, if 5 is a root of a polynomial, x minus 5 is a factor. And if 7 is a root, then x minus 7 is a factor. So here what we've got is we have got 3 roots, right? -2, -1/2, and +3, which means we also know the 3 factors, right? The factors will be x minus -2, which is x plus 2. And another factor will be x minus x minus -1/2, which is x plus 1/2. And another factor will be x minus 3. Okay, so those are our 3 factors. And it's conventional, right? Instead of writing x plus 1/2, we could factorize out the half and say that that guy there is actually the same thing as having a factor of 2x plus 1, right? Because, you know, this factor and that factor are basically the same. All I've done is I've just factorized out a half. So if this is the case, right, then f of x is going to be equal to the product of these factors. So x plus 2 times by 2x plus 1 times by x minus 3, but times by some constant. Okay, and the constant we don't know yet, but what could we do? Well, we could find it out by using the y-intercept, right? Because when x is equal to 0, y is equal to 2. So if we substitute in here, right, when x is equal to 0, y is equal to 2. So 2 will equal to k times by 0 plus 2, which is 2, times by 0 plus 1, which is 1, times by 0 minus 3, which is minus 3. Okay, so we get 2 is equal to k times by -6. And that would mean that k would be equal to -2 divided by 6, which is -1/3. Okay, and of course we've got to deal with the fact that this is a modulus function, right? So there are two kind of things that could have happened. Either our function could be this positive cubic; it could be like that, right? So the positive cubic kind of would do that. Sorry about that. And if that's the case, actually our y-intercept would not have been +2, it would have been -2. Or alternatively, we could have had this cubic, which would have been the negative cubic, and it would have looked like that. Okay, so because that's the case, actually, our k could have been -1/3, in which case we'd have got the blue cubic, right, this guy, or k could have been +1/3, in which case we'd have got this cubic here. And so therefore the two possible outcomes are f of x is equal to plus or minus 1/3, bracket, what were our factors again? X plus 2, 2x plus 1, and x minus 3. Okay, and that should be our answer. Okay, question 2, we are asked to solve the equation x to the power of 1/3 plus 1 is equal to 6 over x to the power of 1/3. And I think the key to doing this is to notice that this is a hidden quadratic, and we're going to do that with a substitution. Let u equal x to the power of 1/3. And if we do that, then we get u plus 1 is equal to 6 divided by u. And I multiply everything through by u, so that becomes u squared plus u on the left, and it becomes 6 on the right. And that's a quadratic, isn't it? U squared plus u minus 6. And that should be fairly easy to factorize without a calculator, because we're looking for two numbers that multiply together to give -6 and that add up to give +1. So that's going to be u plus 3 and u minus 2. So we end up with u is equal to -3 and u is equal to +2. But of course, u is equal to x to the power of 1/3, right? So x to the power of 1/3 is equal to -3, and x to the power of 1/3 is equal to 2. So if I cube both sides, x will be negative 3 cubed, which is negative 27, and x will be 2 cubed, which will be 8. So the two answers should be negative 27 and positive 8. Okay, question 3. A circle with center C has this equation here. Show that the line y equals 2x minus 3 is a tangent to the circle. Now, with all of these circle questions, can I suggest that you try to complete the square so you get it in the form x minus a squared plus y minus b squared is equal to r squared. So even though that's not strictly necessary, I think it helps you to understand what the circle is and to do the rest of the question. So I'm going to do that. So I'm going to rewrite this as x squared minus 10x plus y squared minus 4y plus 24 is equal to 0. So what I'm going to do is I'm going to complete the square with that and with that there. So how do I complete the square? Well, I take the coefficient of the x, which is negative 10. I divide it by 2, which is negative 5. So I'm going to get x minus 5 all squared minus 5 squared. And I'm going to do the same thing with the y. I'm going to do negative 4 divided by 2 is negative 2. So y minus 2 all squared minus 2 squared plus 24 is equal to 0. So let's simplify this. We've got x minus 5 all squared minus 25 plus y minus 2 all squared minus 4 plus 24 is equal to 0, which becomes x minus 5 all squared plus y minus 2 all squared, and then 25 plus 4 is going to be 29, minus 24 is 5, right? So this is, I'm going to rewrite it like that. So this guy is a circle, right, with a center at 5, 2, and with a radius of root 5. So even though that is actually not necessary, guys, I just think it is so helpful because you want to understand what this circle is all about. And I think that can help you with the later parts of the question. Okay, so let's actually do part A. Show that the line y equals 2x minus 3 is a tangent to the circle. Now, there are a couple of ways you could do this. But what does it mean if it is a tangent to the circle? So let's imagine that we've got a circle here, right? And then we've got a tangent. So a tangent is a line that just touches the circle like that. And so the intersection with the circle and with the line, there should just be one. So there is one and only one intersection. So if we were trying to solve the equation of the circle and the equation line simultaneously, we should find just one solution. Okay, so that's what we're going to do. We're going to try to solve these equations simultaneously. So I'm going to substitute in, sorry about that. So I am going to substitute in, what's the equation of the line? Y equals 2x minus 3 into the equation. So x minus 5 squared plus y is 2x minus 3. So 2x minus 3, 2x minus 3 minus 2 all squared is equal to root 5 squared. So that's 5. So this becomes x minus 5 all squared plus 2x minus 5 all squared is equal to 5. So expand this, x squared minus 10x plus 25 plus 4x squared minus 20x plus 25 is equal to 5. And collecting all the terms, 5x squared minus 30x plus 25 is 50, minus 5 is plus 45 is equal to 0. And then we can divide through by 5, x squared minus 6x plus 9. And lo and behold, that factorizes to be x minus 3 squared. And so what does that mean? It means we've just got one point of intersection only, which is that x is equal to 3. So only one intersection. And that is when x is equal to 3, right? So that's the point of intersection. So what are we asked to do? Just let's check. Show that the line is tangent to the circle. Well, we have actually done that, okay? So let's do part B. Given that this tangent touches the circle at the point P, find the coordinates of P. Well, we've got that the coordinate is x is equal to 3, so we can just substitute to find our y value. So y is equal to 2x minus 3. Y is equal to 2x minus 3. So when x is equal to 3, y is equal to 2 times by 3, which is 6, minus 3, which is 3. So the point P is 3, 3. And find the equation of the circle which has its center at P and which passes through the origin. Okay, so let's just quickly draw out what's going on here. So, oh, shoot. So, I don't know, 1, 2, 3, there's 3 there. 1, 2, 3, there's 3 there. So the point P is this guy, that's P. And we want a circle that also goes through the origin that's there. So the radius of our circle, right? So if I imagine kind of drawing a circle that goes all the way around like that, the radius of that circle has got to be equal to that length there. Well, so how am I going to find that length from the origin to P? Well, just got a right angle triangle, isn't it? Right, so that's a right angle triangle with length of 3 and 3 there. So my radius squared is equal to 3 squared plus 3 squared, right? So 9 plus 9 is 18. So r is equal to the square root of 18. So I'm just going to leave it like that for the moment. And we want it to have a center at P. So the point P again is 3, 3. So what's the equation of a circle with a center of 3, 3? Well, it's x minus 3 all squared plus y minus 3 all squared is equal to the radius squared. So root 18 squared, which is 18. Right, so that should be the equation of my circle. And just double check that. Yeah, everything there looks good. Okay, all right, I hope that was helpful. All right, question 4, which should be a fairly basic integration. We want to find the integral of sine theta d theta between 0 and pi. Well, if we integrate sine, right, then we should get negative cos. Why do we get negative cos? Well, because cos differentiates to give negative sine, and integration is the reverse of differentiation, right? So that's the principle there. That is something you will definitely need to have memorized. So then what I need to do is I need to substitute in the upper and lower bound. So I substitute in the upper bound first. I get negative cos pi. And I substitute in the lower bound, which is 0. So I get negative cos 0. Well, okay, then because you don't have the calculator, you need to know what cos pi and cos 0 are. So we need to just quickly think again about what cos and sine are. These come from the unit circle, right? The circle of radius 1. So here's our circle of radius 1. And if you see me do this on all the other papers, where I'll give a longer explanation, you will know that I take a point here that's on the circle. And that point makes an angle of theta with the x-axis, and that point has got an x and a y coordinate. Okay, and essentially what we say is I take that point and I drag it all the way around the circle, right? And as I drag it around the circle, the angle is changing, but also the x and the y coordinates are changing, right? So the x and y coordinates are functions of the angle, right? They change depending what the angle is, right? So for example, when the angle is 90 degrees, which means we're here, the x coordinate is 0 and the y coordinate is 1. And basically, the x coordinate is a function of the angle, and we call that function cos. And the y coordinate is also a function of the angle, and we call that function sine. Right? So when you're thinking about sine and cos, right, actually you're not really thinking about triangles. It's not adjacent over hypotenuse and opposite over hypotenuse, right? That's as a consequence, but it is not the actual definition. When we say cos, what we mean is what is the x coordinate on the unit circle when the angle is whatever, theta, right? So if I say cos 90, I mean, what is the x coordinate when the angle is 90? If I say sine 180, what do I mean? I mean the y coordinate on the unit circle when the angle is 180. So in this case, right, we've got cos pi, so we ask ourselves, where is the angle pi radians? Well, it's here, so this is where I am on my unit circle, and it's cos, so what's the x coordinate of that point? Well, the x coordinate's negative 1. So I write and I say cos pi is negative 1, so I've got minus 1 there. Okay. All right. Secondly, what is cos 0? Right. Well, where's my angle 0? My angle 0 is here. Okay. So what's the x-coordinate of that? The x-coordinate is 1. So that's minus 1. Okay. So I've got minus 1, which is plus 1, minus 1, which is plus 1. So that is equal to 2. Okay. So the integration there should be very easy, I think. But where students will go wrong is because they don't know, right, the values of sine and cos at those critical angles, and they will guess. But what I'm saying is you don't actually need to guess. You need to understand the definition of sine and cos, which comes from the unit circle. Okay. All right. Question B. Given that alpha is between 0 and pi by 2, in other words, given that the angle is acute, show that sec alpha over cot alpha plus tan alpha can be written as sine alpha. Okay, well, look, we just need to know the definitions of these guys. So if I've got sec, what does sec mean? Well, we always look at the third letter, right? 1, 2, 3. The third letter is C. So sec is 1 divided by cos. Okay. What is tan alpha? Well, tan alpha by definition is sine alpha over cos alpha, right? So that's like the most basic identity. And what's cot? Well, again, we look at the third letter, right, with sec, cosec, and cot, and the third letter is T. So cot is 1 divided by tan. And therefore, we know that, right? If tan is sine upon cos, then 1 divided by tan, we'll just invert that, will be cos upon sine. So that's all the necessary information that I need. So what I can do is I can take my identity, right? So whatever, I'll call it the left-hand side of the identity. And I can say, well, sec is 1 divided by cos. And I can say that cot is cos divided by sine. And I can say that tan is sine divided by cos. Okay, so I've written it like that. Now, I want to simplify all this. So I'm going to get rid of these fractions on the bottom. And the way I'm going to do that is I'm going to multiply by sine and cos, right, to cancel out those denominators. And that means I've also got to multiply the numerator by sine and cos. So if I do that, 1 upon cos times by sine times by cos, the cos is cancelled, I'm left with sine. And this guy, if I do cos upon sine times by sine cos, then the sines cancel, and I'm left with cos squared. And if I do sine upon cos times by sine cos, then I get sine squared for the same reason. Well, then we can use the identity, right? That cos squared plus sine squared is 1. And so what we end up with is just sine, because we got sine divided by 1. So that's basically our answer. Now, some of you are probably wondering, what does this mean here, right? The alpha is acute. Well, if we just go back to our definition from part A, basically sine and cos, right, refer to the coordinates on the unit circle, right? So cos tells you the x coordinate and sine tells you the y coordinate. So what does this mean? When will cos be positive? Well, cos will be positive whenever the x coordinate is positive, which is going to be on the right-hand side, right? Because the x's are all positive on the right-hand side. When is sine going to be positive? Sine is going to be positive when the y value is positive, right? So it'll be on the top, right? Because these are where y is positive, right? The top two quadrants. Now tan, right? Tan is, there are two ways to think about tan. Tan is like the gradient of this line. Yeah, that's the most basic way to think about it. You could also say that tan is sine divided by cos, which means the same thing, right? Because we've got y divided by x, which is gradient. So when will tan be positive? Well, it'll either be positive when both sine and cos are positive, right? Because positive divided by positive is positive. Or it will be positive when sine and cos are both negative, which is here, right? Because negative divided by negative is a positive. So essentially, all functions are positive in the first quadrant, and only sine is positive in the second, only tan is positive in the third, and only cos is positive in the fourth. Well, if, as the question states, right, we're between, our alpha is between 0 and pi by 2, it means we're in this quadrant, and that means that tan is positive, cos is positive, and sine is positive, right? So everything is positive. So that means that sec, which is 1 divided by cos, is positive. Cot, which is 1 divided by tan, will also be positive, and tan will be positive. So this whole thing here is positive, right? So we don't have any issues where the value of the sine is flipping or changing. Okay, so that's basically it. It's kind of just clarifying that matter for you. All right, question 5. We're given a polynomial here where a and b are integers, and we're told that p prime of -1 is equal to 21, and that x minus 2 is a factor of the polynomial. So what we've got to do, well, p prime means we differentiate. So if we differentiate this polynomial, that should be fairly straightforward. So we're going to get 9x squared minus 14x plus a. So I think that should be relatively easy. And this statement here means if I substitute -1 into here, then I should get 21. So let's just do that. 9 times by -1 squared minus 14 times by -1 plus a is equal to 21. So -1 squared is 1. So that's 9 times 1. Minus 14 times -1 is plus 14. And so on the right-hand side, right, we've got 23 plus a is equal to 21. And so therefore a is going to be equal to -2, right? So that's fairly easy. What's the second thing? Well, we know that x minus 2 is a factor. Well, if we know that x minus 2 is a factor, by the factor theorem, we also know that 2 is a root, right? So if x minus 2 is a factor, 2 is a root. And just for those of you not really sure about why that is, I think I'll just try to explain it, right? Imagine we've got a function f of x, and we've got a factor x minus 2, and we've got other factors as well, and those factors I'll call whatever, q of x. Okay, it doesn't really matter. The point is, right, that if I substitute 2 into this function, then I'm going to get 2 minus 2 here, which is 0. And so this whole thing will be equal to 0. And therefore, that means that 2 is a root, right? Because the definition of a root is a value of x, which if I substitute it in, will give me 0, right? So in other words, you know, if if I've got f of 5, and that equals 0, that means that 5 is a root, right? That's the definition. And what we're saying here is if I substitute 2 in, then this will become 2 minus 2, which is 0. And so the whole thing will be 0. So basically, we know that if x minus 2 is a factor, 2 must be a root, right? That's the explanation. So if x minus 2 is a factor, 2 is a root. So I just substitute 2 into the function, right? So if I substitute 2 in, I should get 0. So I'll get 3 times by 2 cubed, which is 8, minus 7 times by 2 squared, which is 4, plus a times by 2, so a times by 2, plus b, right? We know that that thing's got to be equal to 0. So 3 times by 8 is 24, minus 7 times by 4, which is 28, plus a times 2. We know that a is -2, right? So this guy's -4, plus b. Okay, so b is going to be equal to, well, we've got 28 plus 4 is 32, minus 24 is going to be 8. Okay, so I think that b therefore should be equal to 8. Okay, so we've now got our polynomial. So hence we want to write the polynomial as a product of linear factors with integer coefficients. Okay, so let's just write everything out. So p is 3x cubed minus 7x squared, I think it was. Yeah, plus a, so that's minus 2x, plus 8. Okay, and we know that x minus 2 is already a factor. So to find the other factors, what we could do is polynomial division. So that's what we'll do. We'll take this whole guy here, and we're going to do polynomial division. We're going to divide that guy by x minus 2. Okay, so how do I do the division? I do 3x cubed and divide by this term here, x, and that gives me x squared, or sorry, 3x squared, do beg your pardon. We then take that 3x squared and we times it by the divisor. So 3x squared times by x minus 2 is 3x cubed minus 6x squared. And then having done that, I subtract off. Okay, 3x cubed minus 3x cubed is 0, minus 7x squared minus 6x squared, right, so plus 6x squared is minus x squared minus 2x plus 8. And now negative x squared is my new leading term. So I do negative x squared divided by x is negative x. Again, I multiply negative x with the divisor, which gives me negative x squared plus 2x. I subtract that off. So minus x squared minus x squared is 0. Minus 2x is minus 4x plus 8. So minus 4x is my new leading term. I divide it by x, I get minus 4. And I take the minus 4, multiply it by the divisor, which is minus 4x plus 8. And of course, if I subtract off, I get 0 as the remainder, which is what I expect. So what have we just done? We have just said that if I take the polynomial p of x and I divide it by x minus 2, then what I get is I get that quadratic, 3x squared minus x minus 4. Right, so 3x squared minus x minus 4. And of course, we can rearrange that by multiplying by x minus 2 on both sides. So we get x minus 2 times by 3x squared minus x minus 4. And the question asks us, right, to write it as the product of linear factors. So we're going to want to try to factorize this quadratic here. Okay, well, we don't have a calculator. So what's going to go on? Well, we know we're going to have a 3x and we're going to have an x. And we're going to be looking for two numbers that are going to multiply together to give negative 4. But it's going to combine in such a way that we get a negative 1x. Well, what are the alternatives? We could have like 4 and negative 1 or vice versa, or 2 and negative 2. And let me just have a quick think. I think it's probably going to be 4 and 1, isn't it? So if I make that one plus 1 and this one minus 4, I think that's going to work, isn't it? Because minus 4 times positive 1 is minus 4, but I've got minus 4 times x, which is minus 4x, plus the 3x will give us negative x. So I think that's going to be our answer. Now, of course, if you couldn't do that by factorization, what you could do is you could solve using the quadratic formula, right? So the quadratic formula will give you roots, and therefore, if you've got the roots, you can find the factors. So is that all I'm supposed to do? I think that's all I'm supposed to do. So I'm just going to check my answer against the mark scheme, see if everything is correct there. So let me just do that. X minus 2, x plus 1, and 3x minus 4. Yep, that's all correct. Okay, then part C of this question, which looks like it's really rather complicated, but if you see a certain trick, it's actually not too bad. So we got this guy here, using our values of a and b, solve this equation here. So we're going to rewrite this. We're going to rewrite it in the following way. We've got 3 times by e to the 2y cubed minus 7 e to the 2y squared plus a. Now our a was negative 2, wasn't it? So negative 2 e to the 2y plus b, and I think our b was 8, wasn't it? Let me just go back and check. Yeah, 8. So we've now got this polynomial here, right? Or not polynomial, we've got this function here. And this is very, very similar to the polynomial we had before, right? It's very similar to, where was it? To this guy, okay? Because instead of the x's, what have we got? We've got e to the 2y. So actually, what is this guy? This polynomial is p of e to the 2y, right? Because all I've done is I've taken the previous polynomial and I've substituted in place of x e to the 2y. Well, that means, right, that it can factorize in exactly the same way as our previous functions. So we just go back over here, right? So p to the x can be written as these linear factors. So I can then factorize this guy as being, instead of x minus 2, it can be e to the 2y minus 2. And instead of 3x minus 4, right, it's 3e to the 2y minus 4. And instead of x plus 1, it is e to the 2y plus 1, right? So that's really the key thing. And so therefore, if we're trying to solve when this is equal to 0, right, we want to solve when this is equal to 0, either this factor is 0, or that factor is 0, or that factor is 0, right? So if e to the 2y minus 2 is equal to 0, that means that e to the 2y is equal to 2. And that means that 2y is equal to ln 2. And so y is equal to a half ln 2. or if you prefer, ln of root 2, right? That's absolutely fine. Alternatively, what if this factor is 0, right? Then that means that 3e to the 2y minus 4 is equal to 0. So e to the 2y is equal to 4 upon 3. So 2y is equal to the natural log of 4 upon 3. And so y is equal to a half of the natural log of 4 upon 3. And then the last guy, if e to the 2y plus 1 is 0, e to the 2y plus 1 equals 0 means that e to the 2y is equal to negative 1, and that has no solutions. So we've just got two solutions, a half ln 2 and a half ln 4 upon 3. And I'm just going to check the mark scheme, make sure that that's all right. And that is exactly right. Okay. Okay, question 6. When ln y is plotted against x cubed, a straight line passing through these points is obtained. Find y in terms of x. So if we plot ln y against x cubed, right, then what we're going to get here is ln y is equal to m times by x cubed plus c, right? So this is a straight line because what have we really got? Well, if we replace the ln y with capital Y and we replace the x cubed with capital X, then what we get is a y equals mx plus c graph, right? So that's a straight line graph. So what do we got to do? We've got to find the gradient m, and we've got to find the y-intercept c. So that should be fairly easy. We take the gradient of our 2 points. So the gradient is y2 minus y1, so 25 minus 5. 25 minus 5 over x2 minus x1, which is negative 8 minus 2. And so that's going to be 20 over negative 10, and that's equal to negative 2. So the gradient is negative 2. So we can write this down and say, okay, we've got capital Y is equal to negative 2 capital X plus C. And we can just substitute in one of these points. Let's substitute in the point 2, 5. So we got 5 is equal to negative 2 times by 2, because that's our x value or our x cubed value, plus C. So C is going to equal to 9. And so therefore we can write down and say, well, y, big Y, is equal to negative 2 big X plus C. And we just then replace our big Y with ln y and our big X with x cubed. And now we just need to rearrange it to get y in terms of x. Oh, sorry, instead of c, right? I should have written 9 there, do beg your pardon, because we just found out c is 9. And we will convert this into indices form, right? So ln e is log base e. So therefore we know that y is equal to e to the power of negative 2x cubed plus 9. Okay. Now, for those of you who are doing these questions, can I just suggest that you do it in this way, right? So you write it as big Y equals m big X plus C, right? You just convert it into a straight linear equation. Because then I think it makes it easier. You don't get confused. So essentially these coordinates are not in terms of little y and little x. They're in terms of big Y and big X. Okay, find the value of x when y is equal to e to the power of 25. Well, I think the easiest thing to do is we can just substitute it into here, right? So we had y is equal to e to the power of negative 2x cubed plus 9. Right, so if y is equal to e to the 25, then we get that. And obviously it's the case that the two powers must be the same, right? So 25 must be the same as negative 2x cubed plus 9. So 25 is equal to negative 2x cubed plus 9. So we subtract 9 from both sides. So 16 is equal to negative 2x cubed. So x cubed is equal to negative 8. And therefore x, if we cube root both sides, will be negative 2. So the value of x is negative 2. Okay, question 7. A geometric progression has a fourth term of this and a sixth term of that, where k is a constant. The common ratio of this geometric progression is positive, and find the common ratio in terms of k and the value of the first term. All right, so we need to know the formula for the nth term of a geometric progression, which is a, the first term, times r, the common ratio. Sorry, it looks like a negative there, doesn't it? Times by r, the common ratio, to the power of n minus 1. Okay, so if we've got the fourth term, right, then that will be AR cubed, right? So AR cubed is equal to 8k to the power of 6 over 27. And the sixth term will be AR to the power of 5 is equal to 32k to the power of 10 over 243. And what we want to do is we want to find the common ratio. Well, the easiest thing to do, right, is to divide this thing by that thing, because it means we can cancel off the a's. However, before we do that, I think it's important that we recognize that 8 and 27 can be simplified, and we'll simplify them as powers of 2 and 3. And the same thing with 32 and 243 here, right? So I'll just go down. 8 is 2 to the power 3. And 27 is 3 to the power 3. Okay? And then 32 is 2 to the power 5, right? Because 2 to the power 3 is 8, to the power 4 is 16, to the power 5 is 32. And 243, well, this is slightly harder to know, right? But I think you should know the powers of 3. So 3 squared is 9, 3 cubed is 27, 3 to the power 4 is 81, and 3 to the power 5 is 243. So I think that is slightly hard, but because you're doing a non-calculator paper, you should be able to recognize that that is a power of 3. And the fact that you've got 27 here, I think, is a clue to that. All right, so now what we're going to do is we're going to do AR to the power of 5 divided by AR cubed. So we're going to take basically this guy and divide it by that guy. So we get 2 to the power of 5, k to the power of 10 over 3 to the power of 5, divided by 2 to the power of 3, k to the power of 6 over 3 to the power of 3. And, if we're dividing one fraction by another, then what we can do is we can flip the second fraction and multiply. So I'll write this out in full. 2 to the power of 5, k to the power of 10 over 3 to the power of 5 times by 3 to the power of 3 over 2 cubed k to the 6. Okay, so that's the right-hand side. Now what's happening on the left? Well, as I said, the a's cancel, so that disappears. And we divide top and bottom by r cubed. So we're left with r squared, right? So this guy here is r squared. And now hopefully we can simplify the right-hand side, right? So we divide top and bottom by 2 to the power of 3. So that guy is going to become 2 to the power of 2. And we can divide top and bottom by 3 to the power of 3. So that guy disappears and we get 3 to the power of 2. And we can divide top and bottom by k to the power of 6. So that disappears and that becomes k to the power of 4. So if I write this out in full, I get 2 to the power of 2 times by k to the power of 4 over 3 to the power of 2, right? And so therefore, if I square root both sides, r will be equal to 2 times by k squared over 3, okay? And we could have plus or minus, right? But if we just read the question, we're told that the common ratio is positive. So we're just going to straight up say that r is equal to 2k squared, beg your pardon, over 3. Okay, well, if that's the case, we also want to find the first term, right? So we can use this guy. So AR cubed is 2 to the power of 3, k to the power of 6 over 3 cubed. So let's just go down. Right, so AR cubed, let's just check it again. AR cubed is 2 to 3, k to 6 upon 3 cubed. Okay. Okay, and so now if I just substitute in my r, so I got a times by 2k squared over 3 cubed is equal to 2 to the power of 3 k to the power of 6 over 3 cubed. Well, actually, this guy here on the left is the same thing as that guy there on the right, isn't it, right? That's going to give me 2 cubed, k to the power of 6, and 3 cubed. So I can just divide through by this term on both sides. And so what I'm left with is a is equal to 1. Okay, so that's kind of nice. All right, so a is 1, and my r is 2k squared upon 3. So part B, oh, wait, I got the wrong thing there. Just give me 1 second. That's the wrong question. Okay, so that's the right question, right? So given that this geometric progression has a sum to infinity of 3, find the possible values of k. Well, we just need to know the formula for sum to infinity. So the sum to infinity is equal to a over 1 minus r. So I think we can just substitute in, right? The sum to infinity is 3. A is equal to 1. and r was what was it? 2k squared upon 3. Okay, so 2k squared upon 3. I think I'll simplify the fraction, and the way I'll do that is I'll multiply top and bottom by 3, like that. So times top and bottom by 3, dun, dun. And that would give me 3 on the top. 3 minus 2k squared is equal to 3. So I'll multiply both sides by 3 minus 2k squared. So 3 bracket 3 minus 2k squared. Actually, I'm doing this kind of stupidly, aren't I? I should have just flipped the fraction. Why did I not do that? Never mind. It's all right. Cancel both sides. That becomes 1. So 3 minus 2k squared is equal to 1. Which means that 2k squared is equal to 2, which means that k squared is equal to 1, which means that k is equal to plus or minus 1. Okay, now is there any other condition? The geometry, find the possible values, right? So k is either plus or minus 1. Okay. All right then, question 8. So it is given that y is equal to ln 3x squared plus 16 over x plus 2. Find dy dx when x is equal to 0, and give the answer in the form of ln p, where p is a constant. Okay, well, we've got one function divided by another function, so we need to use the quotient rule. So quotient rule, we say let that guy be u, and let that guy be v. Okay, and so what is the quotient rule? Well, y prime is equal to v times by du dx minus u times by dv dx all over v squared. So that's the rule. So if we're a little bit shaky on this, the best thing to do is we just do each thing separately. So if our u is ln 3x squared plus 16, and our v is x plus 2, then let's just differentiate both of those guys. So u prime, if I differentiate ln, the thing inside the ln, right, the argument of the ln, that goes on the denominator. So 3x squared plus 16. Then we differentiate that term, which gives us 6x, and we stick it on the numerator. So that's differentiating the ln. And v prime, well, if we differentiate x plus 2, differentiate x, we get 1. So now we've just got to substitute all of this into the formula for the quotient rule. So v is x plus 2 times by u prime, which is 6x over 3x squared plus 16. That's that guy. Minus u, which is, where is it? Ln 3x squared plus 16 times by v prime, which is 1. And all divided through by v squared, which is x plus 2 all squared. And, you know, sometimes when we do this, we've got to simplify everything, right? But actually in this question, that's totally unnecessary. Why? Because we're asked to find the value when x is equal to 0. So all I'm going to do is just substitute x is 0 into here straight away. That's going to make my life a lot easier. So when x is equal to 0, y prime is going to be equal to 0 plus 2, which is 2, times by, well, 6 times by 0 is 0, isn't it? So it doesn't actually matter what's on the denominator. Totally irrelevant. Next, we've got ln 3 times 0 squared, so that's 0, plus 16, so it's ln 16, times by 1, so no change there, over 0 plus 2, which is 2 squared. So 2 times 0 is 0, isn't it? So we get negative ln 16, all divided through by 4. Okay, and what are we asked to do? We're asked to leave it in the form of ln p, where p is a constant. Okay, well, what would I do here? I think the best thing is I'm going to write that 16 as 2 to the power 4. So that's that, over 4. I can use the log rule to bring the 4 down. So I write that as negative 4 ln 2 over 4. Right, so if you're a little bit confused about that, the rule I've just used is that log of a to the power of p is equal to p times log a. That's what I've just done. So I've brought this power down, brought it down to the front, and I can then cancel off the 4s, can't I? Cancel, cancel. So that's equal to negative ln 2, and that's probably almost right, isn't it? But I'm a bit suspicious because the question just says leave it as ln p, not negative ln p. So what I'm going to do is I'll take that negative 1, right? So it's like negative 1 times ln 2 and bring it up. So we get ln of 2 to the power negative 1. And 2 to the power negative 1 is a half. So I think the answer that they're looking for is ln a half. Although, to be honest, negative ln 2, I think is a bit more elegant, but never mind. So I'm just going to check the mark scheme, see what they actually want. They want ln a half. Yeah, okay, so that's the right answer for that. Then part B of this question, given that x increases from 0 to h, where h is small, write down the approximate change of y. Okay, well, this is an approximate change question, so we use the formula delta y upon delta x is approximately equal to dy dx, calculated at our point, right? So whatever our point is, call it p. Now, I've explained this in other videos, but I think this is fairly straightforward, so I'm not going to go into great detail here, but if you want to see me explain why this formula is true, you can look at one of my previous videos. So what am I going to do? We already know dy dx calculated at the value of x is equal to 0, right? We've done that in part A, so calculate x is equal to 0. That's equal to ln of a half. Okay, and our delta x, right, is equal to h, because that's the small increase in x. And we want to find the approximate change in y, so we're being asked to find delta y. So essentially, what do we got here? We've got delta y divided by h is approximately equal to ln a half. And so therefore, delta y, the approximate change in y, is ln a half times by h. And that should be our answer. Yeah. All right, question 9. It is given that f of x is 2 ln 3x minus 4 for x is greater than a, and that the inverse function exists. Find the least possible value of a. Okay, so for a natural log graph, basically we need to know that the value inside the natural log, the argument, must be a positive number. So we know that 3x minus 4 must be greater than 0. Therefore, x must be greater than 4/3. Okay, so x is greater than 4/3. And so we can just say a is 4/3, yeah? For your value of a, find the range of f. Well, I think it's helpful just to know what a natural log graph looks like, right? So I'll just sketch it here. A natural log graph like y is equal to ln x. It has an asymptote of the y-axis. Kind of goes up like that. And it goes up through x is equal to 1 and kind of goes like that. So that's the graph of y is equal to ln x, right? So asymptote on the y-axis, the line x is equal to 0, and x-intercept at 1. Now, what do we notice from that? Well, we notice that the range of the natural log graph is all of the possible values of y, right? So these are like all the real numbers. So in the case of this function, right, essentially because our log graph is everything from the asymptote onwards, right? So we haven't cut this log graph in any way, right? Let's say the domain was like, instead of 4/3, like the domain was everything is greater than 2, then what we would have done is we would have cut the graph. But we haven't cut the graph in this case, so we can just say, okay, the whole graph is there, and so the range is all the real numbers. Okay, so that's that. Part C, find an expression for the inverse function. Well, it's important to understand what inverse functions are, so let's just try to do that very quickly. So imagine we've got an original function f, right? What does that do? Well, we take in inputs x, and that function gives us outputs y. So what's an inverse function supposed to do? Well, it's supposed to take those outputs y and give us back the original inputs x, right? That's its job. So for example, if we had an input into the original function of 3 and we got an output of 10, what that means is if we put 10 into the inverse function, we should get back to 3. That's the job. So if we think of it that way, right, what does the function do? Original function, that is. It tells us the y, the output, in terms of x, the original input. So what's the job of the inverse function? What's the job of this guy? Is to tell us the x value in terms of the y value, right? So basically, we just take our function and we rearrange it to get x in terms of y. So if we've got y is equal to 2 ln 3x minus 4, I think that was it. Let me just double check that. Yeah, 2 ln 3x minus 4. We're just going to rearrange it. So y upon 2 is equal to ln 3x minus 4. So we can raise this, we can convert it to exponential form. E to the power of y upon 2 is equal to 3x minus 4. So x is equal to 4 plus e to the power of y upon 2 divided by 3. And then by convention, we rewrite this, right? Because we like the input variable to be called x. So we just replace the y's with x's. We get 4 plus e to the power of x upon 2 over 3. So let me just check that that is all correct. Yep, that's all correct. Okay, so now let's look at the second part. Let's look at part D. So it is given that the equation f of x equals the inverse has two roots. Now I'm going to return to this in a little moment, okay, because there's some information that I'll need to explain there. And for our value of a, sketch the graphs of f of x, f inverse of x, label each graph, state the intercepts of each graph with the axes, and state the equations of any asymptotes. Okay, so we already know the asymptote, right? We know that x must be greater than 4/3. So the asymptote is going to be at 4/3. What's the intercept of our f of x graph? Well, we can actually find it very simply by setting the argument equal to 1. So we could do 3x minus 4 is equal to 1. But let me just try to explain why that is. So y is equal to 2 ln 3x minus 4. X-intercepts, right, are where y is equal to 0. So 0 is equal to 2 ln 3x minus 4. So 0 is equal to ln 3x minus 4. So e to the power of 0, convert it to exponential form, is 3x minus 4. And what's e to the power of 0 is 1. Right, so what did I say just a moment ago? If you really want a fast way to get the x-intercept, you just set the argument equal to 1. That's the fastest way. So if we rearrange that, we get 3x is equal to 5, so x is equal to 5/3. So what do we got here? We know that we've got 1/3, 2/3, 3/3, 4/3, and 5/3. Now, what happens at 4/3? Well, we know that we've got our asymptote, right? So let's kind of draw on the asymptote at 4/3, like that. Boing, 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 boing. And we've got our intercept at 5/3, right? So that's going to be there. So I've got to label this, right? That's 4/3, that's 5/3, like that. And so my graph is going to kind of come up like that. Now, however, there's more to this now. We've got to deal with this whole inverse function with f of x equals f inverse has got two roots. What does this mean? It means that the original function is going to intersect the inverse function twice. Now, in order to understand that, right, we need to understand that a function reflects its inverse along the line y equals x, right? So if I draw the line y equals x, then the graph of the inverse function should be a reflection of the original function in that line, right? So that means, for example, that the asymptote gets reflected. So we get an asymptote at x is equal to 4/3. And we also get a y-intercept at 5/3. Okay, so this value here is 4/3. This is 5/3. And sorry, by the way, like that intersection of those two asymptotes should be on the line y equals x. So I've kind of drawn it a little bit badly. Please forgive that. So then what else has got to happen? Well, if these two graphs, the function and its inverse, intersect twice, then they've got to intersect along the line y equals x. That's where they've got to intersect. So we're going to have two intersection points, right? And I'll draw them whatever, like here and here, I guess. So if I was to draw my function f, let's try to draw it like that. Oh, this is going to be pretty bad, and I do apologize in advance. So let's say it looks something like that. Okay, do beg your pardon, something like that. That's not great, is it? Never mind, it's good enough. And then the inverse function I'll do in yellow. So it's going to like follow that trajectory as well, but it's now got to intersect there. Ooh, and it's got to kind of curl up, and it's going to intersect there. So hopefully what you can see is that the yellow and the blue are reflections in the line y equals x, and we can see that they intersect each other at 2 points, and those intersection points have got to be along the line y equals x. So I think that should be your full graph. So yeah, so I'm just check the mark scheme. Yeah. So they want something like that. And there are 4 marks available. One for having f of x in the first and the fourth quadrants, and another mark for having the 2 intersections, another mark for having the x-intercept at 5.3, and another one for having the asymptote at 4.3. Okay, so those are the 4 marks. Okay, all right, I hope you found that helpful. Okay, question 10, which is a circular measure style of question, and I've shrunk it down so that we can fit it on the page. Diagram shows this shape. AOF is a straight line, so that's a straight line. OAB and OEF, that are sectors of a circle with center O, radius of R. Angle BOA, right, BOA is equal to EOF, right? So in other words, we're told that this angle here is the same as that angle there, right? Those two are identical. OCD, so OCD is this guy, that guy, is a sector of a circle with a center O and radius 4r upon 3. Okay, well, wait a second. If that guy there is a length of r, and that guy length is 4r upon 3, then this length has got to be 4/3 of r minus r, which is going to be 1/3 of r, right? So I can just write that that length there is r upon 3, or 1/3 of r. So I'm going to do that straight away. Angle COD, yeah, COD is theta radians, and the point B lies on the line OC, and the point E lies on the line OD. Okay, so that's a straight line, that's a straight line. And the line BE is parallel to the line AOF, right? So BE parallel to AOF. Find, in terms of r and theta, the area of this shaded region here. Now, you probably think it's very tedious for me to go through all this information. But one of the things I found, right, is the reason students go wrong with these questions is because they make false assumptions. They make wrong assumptions. So you can't do that. You actually do need to read it through carefully just to make sure you haven't assumed that like some angles are equal or an angle is a right angle or anything like that. Just be very, very careful. Okay, so that's the first point. Okay, so then how are we actually going to find the area of the shaded region? Well, this is the area of a sector, isn't it? That guy, so OCD, minus the area of a triangle, right? So what I'm going to do is I'm going to define this, right? I'm going to say we're going to find the area of this sector here, right? So that guy like that. Okay, so we're going to find the area of that sector, and we're going to subtract away from it the area of this triangle. All right, so that's my objective. We're going to do that like that. Okay. So what's the formula for the area of a sector? Well, it's equal to a half r squared theta. So it's a half r squared theta. And what's the radius in this case? I probably shouldn't have used little r, right? Because like that's going to be confusing. We'll use big R just to differentiate it. What's the radius of the sector? The radius of the sector is the 4r upon 3, right? So it's that guy. So we've got a half of 4r upon 3 squared times by theta. So let's just expand this, right? We're going to get 16r squared upon 2 times by 9 theta, which is going to be 8r squared theta upon 9. That's the area of the sector. Okay, so how are we going to find the area of the triangle? I think we can just use the sine rule, right? So area of the triangle is equal to a half, I'll call it BC sine A. So in other words, the area of this triangle is equal to a half of that length times the sine of that angle. So it's equal to a half of, so the two lengths are both equal to r, so r times the sine of theta. So that's going to give us a half r squared sine theta. So then the shaded region, the area shaded, is just the difference. The area of the shaded is equal to the 8r squared theta upon 9 minus the a half r squared sine theta. And I'm just going to check the mark scheme, see what kind of form they want the answer in. Oh, they were happy to have it not simplified. Okay, a half 4r upon 3 squared theta minus half r squared theta, right? So they're happy. They're happy with that. Okay. All right, then part B of this question. So the diagram shows the shape from part A, but this time with a different region that's shaded, this guy here. We want to find in terms of r and theta the perimeter of the shaded region, right? So what does that actually involve? Well, we've got this length here. That's easy, right? That's just r plus r. And then we've got this length here, right? And this length here, which are both the arcs of this sector. So we know that that angle is the same as that angle. And because these two radiuses are the same, the length AB will be the same as the length EF. So how do I find the arc of a circle, arc of a sector, whatever? It's equal to the radius times by the angle, right? So r theta, but we've already used theta in this question, so I guess I'll use phi just to make sure it's different. So what's this angle here in blue? This whole angle, right, from there to there is going to be pi radians, right, because that's a straight line. So if we subtract off theta, then both of these angles are going to add up to be pi minus theta. And so each one of those angles will be pi minus theta divided by 2, right? So this angle here will be pi minus theta divided by 2. And this angle here will be the same, pi minus theta divided by 2, right? So that's fairly, can do that by calculating. And so what's the arc length going to be? Well, we take the radius, which is r, and we times it by the angle, which is pi minus theta over 2. So we know that the length of AB is equal to that, and we also know that the length of EF is equal to that, right? So we can just do this and multiply it by 2, and that will give us the length of that plus that. So what else do we need? We need to find this length here. Okay, so the length of BE, and we can do that using the cosine rule. What's the cosine rule? A squared is equal to B squared plus C squared minus 2BC cosine of A. So what does that mean? It means that this length squared is equal to that squared plus that squared minus 2 lots of that times by that, the cosine of that. Right, so I can basically say the length BE squared is equal to r squared plus r squared minus 2 lots of r times by the cosine of the angle theta. So this will be 2r squared minus 2r squared cos theta. So I can factorize out, I guess, 2r squared, bracket 1 minus cos theta. And so therefore, if I square root both sides, right, BE will be equal to r times by the square root of 2 bracket 1 minus cos theta. Okay. Okay, so that's the length BE. So what's the total perimeter? Right, so the total is going to be what? Well, let's just go around. We have got this length here, which is r plus r. So we've got 2r. And then we've got these two arc lengths, right? That and that. So each of those is equal to this, but we times it by 2 because we've got 2 of them. So plus 2 lots of r times pi minus theta over 2. And then we've got to add on this length here for BE, which was r times the square root of 2 bracket 1 minus cos theta. So let's just simplify all of this, right? So that's 2r. We can cancel off the r's here. So gone, gone. So we end up with r bracket pi minus theta plus r square root of 2 bracket 1 minus cos theta. And again, I'm just going to check the mark scheme to see like how far they actually want it to be simplified or whether they're content with that. So let's just have a quick look. Yeah, they're absolutely fine. So that's okay, or equivalent, by the way. So if you see on the mark scheme, just to let you know, if you see the letters OE, it means or equivalent. So what I've written here is equivalent to what they've got in the mark scheme. So everything is fine. Okay. Okay, this is question 11. I'm very sorry that the type is small, but I've had to shrink it so I can fit it on the page. The diagram shows the triangle OAB, so it's that guy, where OA is the vector A, OB is the vector B. The point P lies on OA, such that OP is 3/4 of OA, And the point Q lies on AB, so on that line there, such that A to Q is a third of A to B. And the straight line through P and Q meets the straight line through O and B at the point R, right? So that's a straight line, goes to R. It is given that OR is equal to lambda B, okay? And PR is equal to mu times by PQ, where lambda and mu are constants, okay? Now, the first question is we are asked to find OR, the vector OR, in terms of the vectors A, B, and mu. Okay, so we want to go OR. Well, what's this go? We got the vector P to Q is, the vector PR is mu lots of the vector P to Q. So what can I do? I can say, well, firstly, O to R, right? How can I go from O to R? Well, I could go O to P, and then I can go P to R. So let's do that. So OR is O to P, and then after that, it's P to R. But wait a second, we're told in the question that the vector O to P to R, beg your pardon, is the same thing as mu times PQ, right? So we can write that. And what about OP, right? We don't know what OP is in terms of A and B, but we are told here that it's equal to 3/4 of OA, right? So I can replace the vector OP with 3/4 of OA. Okay, now what about the vector PQ? What do I know about that? Well, P to Q I could write as being P to A and A to Q, or I could say it's P to O and O to B and then B to Q. So I think it's easier to do the other way, so let's do P to A and A to Q. So I'm going to write this is P to A plus A to Q. Okay? All right, so we've now got 3/4 OA. That's not a problem. We just can call that little a. But what about this vector here, PA? Can I simplify that in any way? Well, we know that O to P is 3/4 of OA. So that means that P to A has got to be the remaining 1/4 of OA. So I can write that as just 1/4 of OA. And what about the vector A to Q, right? What do I know about that? Well, I'm told in the question that AQ is a third of AB. So I'm going to write AQ is a third of A to B. Okay? All right, so this is 3/4 of A plus mu times 1/4 of A plus a third of. Now, we need to know what the vector AB is. So how can I go from A to B? Well, I could do A to O and then O to B, right? So this is A to O plus O to B. I'm sure most of you do know, I can just write that as OB minus OA, right? But I'm just being really, really careful, really meticulous here to explain it to those of you who are a little bit unsure. So everything here remains the same, right? And then I've got a third of, well, AO is the same as minus OA, right? Why is it the same as minus OA? Well, because if I go from A to O, it's like I do O to A, just in the opposite direction, right? So AO is equal to negative OA plus OB, okay? So now everything is pretty much set up. So I'm just going to replace the vectors OA and OB with little a and little b. So I've got 3/4 of little a plus mu lots of 1/4 of little a minus a third of little a plus 1/4 of little b. Oh, not 1/4, plus a third of, beg your pardon, expanding wrong, a third of little b. Okay, so I want to simplify this as much as possible. So we've got 3/4 of a plus mu lots of, well, I've got 1/4 a minus a third of a, right? So 1/4 is 3/12 and a third is 4/12. So I've got 3/12 minus 4/12, so that's minus a 12th. So I've got minus a 12th of a, and I've got plus a third of b. A third of b. So this guy becomes then 3/4 of a minus a 12th mu of a. So I can write it as 3/4 minus a 12th mu times by the vector a plus a 3rd mu times by the vector b. Okay, so that's our vector O to R in terms of a, b, and mu. Okay, so then what's the second part of this question? The second part of this question is to find the values of lambda and mu. Well, how can I do that? Well, we've got another vector here, which is equal to OR. That vector is lambda b. All right, so I can actually go down and say we also know, right? We also know that OR is equal to 0 lots of A plus lambda lots of B, right? We're told that in the question. So we've kind of got two ways of looking at the vector OR. And both of them are in terms of a little bit of A and a little bit of B. So I can then compare the A's and the B's, right? So the A's here must be the same as the A's there. And the B's here must be the same as the B's there. So I can set up two equations comparing my A's and B's. Right, so the first equation is 3/4 minus 1 upon 12 mu must equal to 0, right? Which means that a 12th of mu is equal to 3/4. So I times both sides through by 12. So mu is equal to 12 times by 3/4. And of course, I can divide top and bottom by 4, right? So cut, that becomes 3. So I get that mu is equal to 9. And if mu is equal to 9, well, I can also compare my b's, can't I? Right, so b, I will get 1/3 of mu is equal to lambda. And so we've got 1/3 of 9 is equal to lambda. And so lambda is going to be equal to 3. Okay, so I get lambda is equal to 3 and mu is equal to 9. And so I think what we should really do at this point is we should try to see whether or not those values make sense. So we're just going to go to our diagram. Okay. So what did lambda represent? OR is lambda lots of the vector B. So in other words, what we're saying is that this vector here, O to R, is 3 lots of this vector here, right? Well, that kind of makes sense, right? 1 lot, 2 lots, 3 lots, that's okay. And we were also told that P to R, which is this vector here, is mu lots of PQ. So in other words, this vector should be 9 lots of that vector. And that kind of makes sense as well, doesn't it, right? Like 1 lot, 2 lot, 3 lots, 9 lots. Okay, so what you want to do is at the end of the question, you want to kind of just go back to the diagram and do a quick kind of common sense check, right? Do these values here, do they actually make sense? Does this match up with the diagram? And, you know, I think looking at it, it seems pretty reasonable to me. Okay. All right, the last question on this paper. Curve is such that its gradient at the point xy is given by this, and the curve passes through this point. Find the coordinates of the stationary point of the curve. Well, hang on, wait a second. If its gradient is given by this, then dy dx, right, or y prime, is equal to that, because dy dx tells you the gradient of the tangent. So dy dx is 5x minus 2 to the power of a third. So that's the first thing you need to realize. Now, what is a stationary point? Right? A stationary point is where dy dx is equal to 0. Right? So a stationary point is when or where dy dx is equal to 0. So in other words, we want to find where y prime is 0. So we're just going to solve 0 is equal to 5x minus 2 to the power of a third, which is the same thing as solving 0 is equal to 5x minus 2. So x is equal to 2 over 5. Okay, so x is equal to 2 upon 5. Now, that's fairly straightforward, but we are asked to find the coordinates, right? So we want to find the y coordinate as well. So how can we find the y coordinate? Well, we will have to integrate this dy dx to find out what y is. So let's go down, right? So we've got dy dx is equal to, what is it? 5x minus 2, yep, to the power of a third. 5x minus 2 to the power of a third. So we are integrating this really, reversing differentiation. So y is equal to, well, I add 1 to the power. So a third plus 1 is 4/3. I divide by the new power, so I divide by 4/3, but dividing by 4/3 is the same as timesing by 4/3. And then I take the coefficient of x, which is 5, and I divide through by 5 as well, right? So I'm also dividing through by 5. So on the bottom, I've got 4 times 5. And I need to remember to add the constant c. Okay, so I've got this now. I think let's tidy it up a little bit. So y is equal to 3/20 of 5x minus 2 to the power of 4/3. Well, what does this thing here actually mean? Right, well, the denominator of the fraction refers to the root. So we are taking the cube root of 5x minus 2, and we are raising that to the power of 4 plus c, right? So the denominator is the root, and the numerator represents just the ordinary power. Okay, now we want to find the constant c, don't we? So we are told that the curve passes through the point 2, comma 32/5. So when x is equal to 2, y is equal to 32/5. So let's substitute in. 32/5 is equal to 3/20 bracket the cube root of, well, let's figure this out. We've got 5 times by 2 is 10, minus 2 is 8. So we've got the cube root of 8, all to the power of 4 plus c. Okay, all right then. So 32/5 is equal to 3/20. Now, what's the cube root of 8? The cube root of 8 is 2, and 2 to the power of 4 is 16, plus c. And I think we can do a little bit of simplifying here, can't we? Right. So I'm going to divide top and bottom by 4 here. So that will be 4, and that will be 5. Right. So 32/5 is equal to 12/5 plus c, and therefore c is equal to 32/5 minus 12/5, which is 20/5, which is equal to 4. Okay, so therefore, right, our equation of the curve is y is equal to, what is it? 3/20 bracket the cube root of 5x minus 2, is it? Yeah. Big pun. All to the power of 4, and yeah, and then plus c, which is 4. So we know that our stationary point was at the coordinate x is equal to 2/5, right? So basically now we just want to find out the y coordinate of that. So when x is equal to 2/5, y is going to be equal to 3/20, the cube root of, so 2/5 times by 5 is 2, minus 2 to the power of 4 plus 4. Well, 2 minus 2 is 0, isn't it, right? So the cube root is 0 is 0, and 0 to the power of 4 is 0, and anything times by 0 is 0. So that's 0 plus 4. So the y coordinate is 4. Okay? And so therefore I think the stationary point is at the coordinates 2/5, comma 4. And I'm just going to check my answer to see if that's right. Let's see, 2/5, 4. Yeah, that's right. Okay, so I think a little bit of patience there, and just carefully working it through, you should be able to do that. By the way, guys, I hope you found these videos helpful. If you have, please like, subscribe, and share them with your friends. Good luck in your exams.